So today we're going to cover still the surface area, but today we're going to talk about pyramids and cones. All right, pyramids and cones. We probably today will only get to pyramids. All right. So a pyramid. Those are the most famous pyramids located where? Don't say Egypt. I know they're in Egypt. Giza. G-I-Z-A. Okay. So a pyramid is a polyhedron. Remember, polyhedron means that it's just constructed from all polygons. Okay. So it's made of all polygons with a polygon base, and the lateral faces meet at a common vertex. And that's called the vertex of the pyramid. That's right here. All right? The vertex of the pyramid is up at the top, okay? So when you think of pyramids, think of having a base, and then the sides all come together at one point right in the middle above it, okay? Pyramids do not have to be square. This is a square pyramid because the base is a square. Most pyramids you see are square pyramids. So the Egyptians all built square pyramids, okay? But it doesn't have to be square pyramids. It could be triangular pyramids. It could be hexagon pyramids, okay? And those are a bit harder to work with. The height, so there's two heights here. One second, Carlos, let me finish this. The height is the distance from the middle or the center of the base straight up to the vertex of the pyramid. So it is perpendicular to the base, okay? Straight up. So if we're talking in the pyramids, you wouldn't measure the height along one of the edges, right? You would measure it straight up and down. Okay, just like you would measure a triangle. The other height that we have is the slant height. The slant height is the distance, the height of one of the sides. So you go to the middle of one of your faces and go up to the vertex, okay? Carlos, Brenda, and then Naomi. Brenda?
Do we need to write that down?
Yes. Naomi? We're going to use the slant height at times, yes? There will be problems where they give us the slant height, okay? The secret to solving pyramids is the Pythagorean theorem, okay? We're going to use the Pythagorean theorem a lot with these pyramids, okay? And I'll show you where that comes in a second. Carlos? What is the question? Perfect. Carlos asked, what if the vertex is not right in the center, right? What if they messed up and they put it off to the side? Those exist. They're called slant pyramids. This is called a regular pyramid because it is right in the center, right? We're not going to talk about slant pyramids. Okay? They're just really ugly. It's just a pain in the butt. Naomi? It will be, yes. I'm going to do that in 1 second. So, are we okay with the terminology? Naomi just asked, the height is going to be a leg of a right triangle, and that's true. You notice this triangle right here. It's going to drop straight down, go over to the slant height. That's going to be perpendicular, and then go back up to the vertex. You see that triangle in the middle? All right, that's what we're going to work with a lot. All right, Nancy? Is the what? Yes, so if this is the edges of my pyramid, the slant height would be from the bottom walking up the side of the pyramid to the top. The height, if this is my pyramid, the height is this distance. Okay? Carlos? No. I doubt it. Maybe. All right. A regular square pyramid has a height of 15 centimeters and a base edge length of 16 centimeters. Find the area of each lateral face of the pyramid. Whoa. All right. Let's just talk for a second. What does lateral face mean? So does that include the base? No. What is the base going to look like? What's the shape of the base? Square. How long is one of the edges of that square? 16. Okay? So it might be helpful. Let's just draw a base. We know that each one of this is going to be 16, right? Are we okay with that? Now, the height goes from the center of the base straight up to the vertex of the pyramid. So if we look, we have to draw something that looks like this, right? And it's going to be kind of hard to draw. So picture this, and I'm going to draw it. Ready? Picture that. So we draw our pyramid. I'm not very good at drawing pyramids, so bear with me. All right? There's my base. It's just been slanted. What shape is that still? It's a rhombus, but it's not. What is it? It's a square. It's just in 3D land, okay? It's still a square, okay? Even though it looks like a rhombus. Whoops. This is my square being shifted over. So this is 16. And then we have to draw. This is where I really mess up. I find it easiest to just draw your vertex right above it. And then draw all your sides. One side. You guess and hope it looks okay. Alright, that looks okay, right? No. What? It's a little too far to the left, but you can see that it looks like a pyramid. Yeah. Alright? Like I said, they don't have to be great. They just have to give you an idea. Now, the other information that they give us is that the height is 15. The height goes straight down to the center of the base. Do you see that? All right, now it's not quite in the center, but you can imagine. Or do you want me to fix this? All right, so this should go right there, right to the center, okay? Now, I said this is all about right triangles. We know that the lateral face, so we know that one side, if you can picture this as being the front, you see there's 4 triangles that go around. Yes. Can you see this as the front side? Yes. The angled side on the front. Are you okay with that? So this is this piece. I just drew the blue piece over here. Yes, it will. Okay. 1 second. What's going to be the base of my blue piece? 16. Because that's the part that touches the square at the bottom. Okay, fine. 15 is the height for the whole pyramid. Okay? So it's not for the triangle, it's for the whole pyramid. All right. Fellas? Excuse me? The blue piece right here, the blue piece on the right. Well, they're the same. This blue piece is the slanted part of the pyramid in the front, going up to the height. And I just redrew it over here, so I drew it flat. Okay? Now, here's the part that gets really tricky. Can I get everybody's attention? We need to find that height, right? Because we want to find the lateral faces. Do we agree that all 4 of those triangles are going to be the same? Okay. So we already have the base. We need to find the height. Well, that height is right there. Do you see that this line cuts from the vertex? Let me draw the vertex in red. This is the vertex of the pyramid. The vertex. Do you see that height, the green, cuts from the vertex to the middle of the bottom of our triangle? Are we okay with that? Yes or no? Kind of. So let me just say it one more time. We took the blue piece, we drew it in the flat version. Okay, so we went from 3D land back to 2D land. The vertex, once again, is still at the top. The 16 is still the base. But in order to find the area of the triangle, we need the base and the height. The green line is my height. Well, where does the green line go? It goes from the middle of the base all the way up to the vertex. So you see that this green line is the same in 2D land and 3D land? Okay. Now, the last thing we need to do we need to connect to this green line. Sorry, that should have been green. The middle of the triangle, the base of the triangle. Excuse me? Yes. So this green is the slant height. So this is the side of a pyramid.
So is that triangle would be just like base of the pyramid?
Yes, it's the front piece of the pyramid. But it doesn't matter because they're all the same.
So then what's the point of having the other in the middle?
Because they're different values. Does that make sense that they're different?
Yeah, but if you're trying to...
Okay, so let me answer this question because it's a good question. The height is straight up and down. The slant height goes to the edge. It's going to be a longer distance from the slant height because you have to walk further, right, to the ground. We need to find the slant height because the slant height is what we care about for the triangle piece. Does that make sense? Do you see how the slant height lies on the triangle? They gave us, however, not the slant height. They gave us the actual height. Okay? How do we figure it out? We use right triangles. Okay? Remember, the height right here forms what with the ground or the base? Right angle. So I'm going to draw that right angle right there. Now it looks funky because it's weird. Do you see this right triangle here? Everybody see that? Now, there's that right triangle. You see it? How long is this distance going to be? Why is it 8? Why is it 8?
Because it's half of all sides of a square going to be 6 using the cross section. So, I mean 16, so you cut one in half.
Okay. So do you notice that this side is going to be 16, correct?
Yeah.
If we move it over here, do you understand that the height's going to hit right in the middle? So this piece has to be 8, and therefore this piece has to be 8. Does that make sense? What is the height for your whole pyramid? 15, and that's given to us in the problem. Are we okay with that? So if I draw this triangle flat, the height again here is 15. The distance to the edge of the pyramid, the distance to this edge over here is 8. And what is this? This is the slant height. And this is x. Do we agree with that? Do we agree with that? Right triangle, can we use the Pythagorean theorem? Pythagorean theorem is a squared plus b squared equals c squared. There's a special triangle there, you probably don't know it. 8, 15, 17. What? Oh, maybe it's 19, I can't remember. 17? Okay. So the slant height then has to be 17. That 17 then is the same as this height here. Do we agree with that?
Yeah.
Alright. So do I have enough information to find the area of that triangle? So the area of this triangle is half the base times the height, which is half the base is 16, the height is 17. We okay still? Question?
So basically you take half of the length of it.
To get the 8? Yeah. Exactly.
You don't have to do all that, you just take half of it, right?
You have to do half of it, and then you have to set up your triangle.
Yeah, but I mean, with all that drawing and stuff, that's what got me confused. I mean, you have to do half of it, but you get all that. Like.
Sorry. If you see it easily, then it's fine. Some people aren't going to see it real easily. Carlos? Correct. I just know that. You could do a squared plus b squared equals c squared, figure it out. So half of 16 is 8. So the area is 8 times 17. I don't know what that is. 136. All right, now, that's the area of one side of the pyramid. But they asked for the lateral area, which is all four of them, right? So we need to take this and multiply it by, so the lateral area, what did they ask for? Oh, we're good. We're already done. So each lateral face just means one of those triangles. So we just found it. It's 136, and it's going to be area, so it's going to be centimeters squared, which means it's a very, very small pyramid. Okay, for a not so famous Egyptian. When you solve pyramid problems, the key is this right triangle right here. Okay? They will almost always give you the length of the base, the height, or the slant height. They'll usually give you two of those. You have to figure out the other piece and then go from there. Okay? So they will almost always give you either the length of each side of the base, the height of the whole pyramid, or the slant height. They'll give you two of those, and then you have to figure out the other one by setting up that triangle. Please remember that the right triangle does not go to the corner. You could form that right triangle if you wanted to. Right? You could go from here all the way to the corner and form that right triangle. But that's not particularly helpful for us. It's a good challenge question. Maybe I'll bonus. All right? They're very hard to visualize. There's what we did. They did it a different way. Notice the base is 16. There's a nice looking pyramid, I wish, right? Their height is 15. The slant height, which is used, an L is usually used for slant height, but I don't care. You can pick whatever variable you want. And then notice that this is half the base because it's half the way along. Okay? Exactly what we did. All right. We'll stop there. I'll keep the homework light, but I want to make sure that everybody does it today, okay? So make sure you spend some time with it. I'll be here after school if anybody needs any help, right? We can pick up with that tomorrow if you want some further practice. That one's slightly harder. Notice that, do they have to be a square pyramid? No. What would this be called? Count again. 6. So it's a base with a hexagon, but it's still a pyramid because they meet, what's this point called at the top? Vertex of the pyramid. What's this called? 14. Slant height. This would be, I don't know if there's a name for that, but that's the distance from the slant height to the center. We'll call that the center, right? And then 10 feet around the bottom. Okay. It's a really long problem. Okay? It's a really long problem. We'll pick up there on Friday, all right? So let me give you your homework. Let me just check what we got here. Oh, this is awesome. Yeah. I play Frisbee for fun, so I find all these Frisbee things. Let's just do 3 and 4, right? There's just two problems. They're both pyramids. They both ask you only to find the lateral face. Number 3 is an odd number, so when you finish number 3, please check your work. And then do number 4, okay? Make sure that they're done when you come on Friday. I will assume that they're done, okay? Make sense? Not bad. They're no worse than the one we just did. I think the first one's easier. The second one's a little bit harder.